Functions are basically reusable blocks of code. When we say functions, we normally refer to user-defined functions because Python also has something called as built-in functions, which we normally use. For example, sum is a built-in function. So sum is a built-in function which returns the sum of all the given elements. For example, if I pass a list of numbers, so the sum function is going to return the sum of all the elements that are sent as the argument. So in this case it's going to return 1 plus 2 plus 3 plus 4, which is equal to 10, right? So what we will be discussing in this video is not this built-in function. We are going to discuss something about user-defined functions, so the functions that we write. So as I already explained, that functions are nothing but reusable blocks of code. So let's check the syntax of writing the functions in Python. We first, to start off, to write any function, we first start with this keyword def, following which we will write the function name. So this is a function name, and then in between the parentheses we can write the optional arguments. We can write optional arguments that the function can expect. Okay, then we write the function definition here. So function definition, or a set of statements that should be executed when this function is called. Okay, so let's write a simple function which returns the multiplication of two numbers. So I'll write def, and the name of my function will be multiplication function, and then it accepts two parameters a and b, or two numbers a and b, and then I will say c equal to a star b, and then I'll say return c. So what this return statement is going to do is it will return this value back. What is the value? It is the multiplication of two numbers a and b. All the functions will have to return something. So but it's optional to write the return statement. Okay, so when the return statement is not returned, something like this, if you have written the function, if the return statement is not written inside the function will return a null object, which in Python is called as none. So by default it will return none. If you don't write anything, this is what will happen. The function will return none. So we don't want to do this. We have to return the multiplication of two numbers in our case. Okay, let's execute this and create this function. So now the function has been created. Let's try to call this function and pass two parameters, pass two numbers, right? So I'll call this multiplication function and I'll pass 2 and 3. So it's going to return the multiplication of these two numbers. So if I execute this, we get 6. Okay, now let's see an example of what happens if we don't write the return statement. So what I'm trying to say is in this case I will simply remove this return statement and check what happens, or what will be the return value from this function. Okay, I'll say x is equal to multiplication function, and I'll pass again two numbers through 2 and 3, right? And now I'll say print x. So ideally speaking, if we had written the return c here, it should be 6. So since we have not written any return statement in this function, let's see what is the value that is going to be coming in this variable x. So if we execute this, we can see that none is returned. Okay, So that is the default return statement of any function in Python if any return statement is not written. Okay, so as part of best coding practice, it is good to write documentation or comments inside the function. Okay, so let's see an example of how we write the documentation or a simple comments inside the function. You can also write the comments like this, or else you can write it in between triple multi-line strings, right? So in between this you can write a simple documentation. So this function, I'll write this function accepts two parameters, or I'll say two numbers, and returns the multiplication of those two numbers. Okay, so it's a good practice to write this kind of documentation or comments about what this function is doing. Okay, so let's talk about the default arguments for the functions. Okay, so while defining a function, we can add some default value to arguments, so that if we don't want to pass any value to that argument, it will consider the default value. So let's see an example to understand this. I'm defining a function def and call the function name as multiply. So it will accept two parameters, a and b. So now I'm going to make the b as optional by just giving it some default value. So now it is optional to send the second parameter or the b parameter to this function. I will simply return a star b. Okay, I'll execute this function. So the second parameter of our multiply function is default or optional parameter with a value equal to 2. Let's first try passing both the parameters. So I will pass both the parameters. For multiply, I will pass 3 and 3. So it will return, so it will override this default value right now. If you pass any value, it is going to override the default value. Now a is equal to 3 and b is equal to 3, and the return statement, the return value from this function will be 3 3s are 9. Okay, so now what happens if we don't pass the second parameter? Okay, I will now pass 3 and just enclose with parenthesis. Now we have not passed any value to the second parameter, but as we know that it is optional, so by default it will be 2. So this time the return value will be 3 into 2, which is equal to 6. Okay, so that's about default or optional parameters to functions. Okay, now let's talk about the variable number of parameters that can be passed to a function. What is variable number of parameters? It means that you can pass any number of parameters that you wish to pass to a function. A function can accept variable number of parameters by writing star symbol before the last variable name. So let me define this function. I'll say sample. So I'll say sample function. So a function can accept variable number of parameters if you just write star in front of it. So for example, this is the variable name args. If I just append star to it, it can now accept variable number of parameters, which means it can accept 0 or more parameters. Okay, so what I'm going to do in this function is I'll simply write a simple for loop for I in the arguments. I'll simply print. So it doesn't matter how many parameters that you're going to pass to this function, it will simply print all the parameters that you're passing to this function. So let me execute this and try to, so since I'm trying to call this function, so since our function can now accept variable number of parameters, I can send as many parameters as I wish to. I'll say sample function. I'll pass, for example, I'll pass two parameters, 2 and 4. Execute this. and it will simply print all the parameters that you are passing. So now I will pass 4 values to this function instead of 2. So I'll say 2, 4, 6, 6 and 8. So what this is going to do is simply print all the numbers that I'm passing to this function. Okay, so now let's talk about the local and global variables. Let's see an example to understand this. I'll define a variable a equal to 5, a equal to 50. This is called as global variable. Okay, if a variable is written outside of a function, then it is a global variable. Now let me define a function. I'll say function 1 2 3, and then I'll say a equal to 12. Okay, and then I'll say return a. Now this variable is a local variable. So by definition, in this example, the variable which is written inside a function, okay, this variable is called as local variable since it is written inside the function. Okay, the one which is written outside the function is called as the global variable. Okay, the point that I want to make here is that even though we are using the same variable name both in the local and global variable scopes, okay, in the local and inside the function also, we are trying to change the value of a equal to 12. Okay, initially we have the global variable a equal to 50, and inside the function we are changing it to 12. Okay, so after execution of the function, the value of global will remain unchanged. So it doesn't matter if you use the same name here inside a function, the global variable will not get changed. Okay, so first I'll print a. Okay, it is 50, right? Now I will execute this function 1 2 3. So it has returned 12 or a. Now let me print a again. You see that the value of a is still equal to 50, which means it is unchanged. So whatever you do inside, if you use the same variable name inside your function and change its value, it is not going to affect the global variable. Okay, but intentionally, if you are really trying to alter the value of a global variable inside your function, if you really want to change the value of a global variable inside your function, you can still do that. Okay, in that case you have to make use of this keyword called as global. Okay, I'll say global a. So when you say global of a, what it's going to do is it's going to convert this variable or whatever variable that we are referring. It assumes that we are trying to refer a global variable and not the local variable. Okay, I'll execute this function. Now I'll print the value of a first. It is equal to 50. Now I'll execute this function 1 2 3. It has returned 12. Now I'll check the value of a, which is the global variable. You can see that it has been changed to 12. Okay, so you can change the value of a global variable inside a function with same name. You can make use of this global keyword. Okay, now let's talk about nested functions in Python. So what are nested functions? Nested functions are those functions in which one function is written inside another function. So let's see an example. I'm creating a timer function using nested functions here. Okay, and I need to use this timer module so that we make the program to run slow and see how the program is performing. Okay, now I'll start creating this timer function using nested functions. So let me define this timer function. So let me create this timer function using this nested functions. So the timer function will accept a parameter n. So if you are passing, for example, 5, it has to count 5, 4, 3, 2, 1. Okay, so it is accepting a parameter n. Inside this function I will write one more function called as display function. It will accept a number. What it will simply do is it will simply print that number and wait for 1 second. Okay, so that is done. So I'll write a simple while loop here. While n is greater than 0, we will call this inner function. So in outer function we are trying to call the inner function. So inside timer function we are calling the display function, which is inside of this timer function, and we will pass this n. Okay, it will simply display that number, and after displaying, let's decrement this number, okay, by 1, so that the loop terminates when n is equal to 0. Okay, let me execute this and create the function. Now what I'll do is I'll call this timer function and pass, for example, 5. So what happens is it's going to go to this while loop and it will call the first the display function. It will print 5, wait for 1 second, and then it will decrement the number. It will become 4, and then again it will call display function and print 4. So this will keep on continuing until the n reaches 0, and once n reaches 0, it will come out of the while loop and it will stop printing any numbers. So let's execute this. So we can see that the timer function has displayed or counted down the numbers starting from 5. So this is an example of nested functions, which are basically nothing but a function written inside of another function. Okay, so that's about nested functions. Now let's talk about something called as recursive functions. Recursive functions are those functions in which the function calls itself for certain number of times. Okay, let's try solving a simple or a problem of finding the factorial of numbers using recursive function. But before that, let's try to understand what factorial is. For example, when I say find the factorial of 5, or what is the value of 5 factorial, it is basically nothing but 5 into 4 into 3 into 2 into 1, which is basically equal to 120. So this is how you find the factorial. So what is the factorial of 3? It is nothing but 3 into 2 into 1, which is equal to 6. So we're going to find out the factorial of a given number using the recursive functions. Okay, so what is recursive function? If a function is being called itself, if a function calls itself, then it is called as recursive function. Okay, now let's define this recursive function. I'll say factorial. It accepts a number n, and then what I'm going to write is if n equal to 1, I'll return 1, else I will return n into factorial of n minus 1. So let's try to understand this better. Okay, but first let's try to call this function and check if factorial is actually working. So I'll say a factorial of 5 and it gives me 20. Okay, now let's try to understand how this works in step by step. Okay, so what happens, so let's assume we are passing 5 to our function. Okay, so what happens in the first iteration? So in the first iteration, n is equal to 5. So it will check this condition. If n equal to 1, n is actually equal to 5, so it will go to else condition, and what is going to return is 5 into factorial of what is n minus 1, 4. Okay, so this is what happens in the first iteration. But what is factorial of 4? So this is equal to 5 into what is factorial of 4? When n equal to 4, it is not equal to 1, so it will again go to else. So it is 4 factorial is nothing but 4 into factorial of n minus 1, so which is nothing but 4 into factorial of 3. Okay, so if you keep continuing this, it will go something like 5 into 4 into 3 into factorial of 2, and then finally 5 into 4 into 3 into 2 into, so when n is equal to 2, yeah, when n is equal to 2, again it will print 1. Okay, it will go, when n is equal to 2, it will go to else condition, and it will return n into factorial of n minus 1, so it will return 2 into factorial of 1, right? So when n is equal to 1 in the last iteration, it will 5 into 4 into 3 into 2 into what is factorial of 1. So when n is equal to 1, it is going inside the if condition, it will simply return 1. Okay, so now the function has stopped calling itself, so it will finally compute this multiplication, which is equal to 120. So this is how this recursive function works. So you have to make sure that when you are creating this recursive function, it has to end somewhere. It cannot keep on calling the same function again and again. There has to be a condition which will stop the recursive, which will stop calling the function itself, or else it will go to the infinite loop. Okay, so this is how the factorial function works. Sorry, the recursive function works. Okay. Okay, now let's look at the decorators in Python, something called as the decorators in Python. The decorators can be used to add new functionalities to an existing function without even modifying the existing function definition. Okay, so let's see an example to understand this better. Let's assume we have a function divide, so which accepts two numbers a and b, and it will simply print the division. Okay, it will divide a and b and it will simply print the result. Okay, I'll execute this, and now if I pass, for example, if I pass 5 and 2, what will be the value? It will be 2.5, because 5 divided by 2 is 2.5. The function works good. But when we divide a number with 0, we get something called as exceptions. Okay, so in the same way, if I pass 5 and 0, we know that we cannot divide a number by 0, so it's going to go into exceptions and give this not so user friendly message. Okay, so in this case we should actually alter the statement, alter the definition of the function, and check whether the second parameter is equal to 0, and then stop division if it is equal to 0. But in case we are not allowed to make any changes inside this function, let's assume we cannot make any changes to this divide function. In that case, we can make use of decorators to perform validations before dividing the numbers. Okay, let's see how we can do this. Okay, so we'll be writing a validation function which accepts. Okay, I'll write a validation function which will actually accept a function divide. So it's going to accept the parameter, the function itself, as a parameter. Okay, so what are we going in writing inside this validation function is we are going to perform some checks on the parameters that are passed to this divide function. Okay, so since we already know that we can write nested functions in Python, so I can write another function called for example final inside this validate function, which will basically get this parameters whatever was passed to this divide function. Okay, now in this final function I'll perform some checks. So if b equal to 0, I will print so what will we print? We'll say cannot divide by 0. Okay, we'll print a user friendly message. Else, if this check is valid, I mean if the b is not equal to 0, we can then return the actual function itself. Okay, so this is what we're going to do, and then we'll say return final. Okay, so now what we can do is we can decorate a function. So I'll copy the same function and paste it here. We can actually decorate this function with our validate function. So without even changing anything inside this function, we can decorate this function along with validate so that it will perform checks and then give the results. Okay, this is how the decorators are actually helpful. Okay, so now what we'll do is we'll call this divide function and pass 5, 0. So now what happens is once we call this divide function, the control will first go to the validation, because since we have a decorator, the control will first go to the validate function, and the parameters that are passed are 5 and 0. So it checks for the second parameter b, it is equal to 0, so it will simply print cannot divide by 0. Okay, now let's just verify that by executing this. So we can see that it prints the message cannot divide by 0, but if we pass something else, it will give the actual result. Okay, so that's all about the introduction to functions in Python.